Guys, we're coming back to trigonometry and Pythagoras in combinations. This is GCSE Higher or iGCSE Extended, and let's have a look at the problem. We are going to find out the most efficient way, and probably here is a bit more about discussions. What apply trigonometry or Pythagoras? Or actually, what you know the best. Okay, that's right time to find out. Pause the video, try to do by your own, that's normally the case, and let's go to explanations. So we are given the radius of circumscribed circle, that's the big one, we mark as that, around the square, which is inside, and the radius is 6 square root of 2 centimeters. Okay, so you need to find the radius of the circle which is inscribed in the square. So that circle is inscribed. Alright, so inner circle, we need to find the radius of that one. Okay, so first, guys, the right time is to put the diagonal. My way is the first one, which is more obvious and clear and understandable. So what I'm gonna do, I'm gonna, from the radius of the circumscribed circle, which is 6 square root of 2, come to basically the side of the square and then come to the radius of the inner circle. So that in this case it's inscribed. All right, and which way we can do this? If I put this as the diagonal of the square, it's going to be a diameter of the circle, right? Because logically this segment, this chord goes through the center, goes through the middle point O. Okay, so in this case it's diameter, and we know that diameter is going to be 2r, 2 radius. So in this case it's going to be 12 square root of 2 centimeters. Okay, we know this red line, actually I denote with the red line, so we know that. And now let's have a look at triangle A, B, and C. All right, angle B is a right angle. We can set up Pythagoras. So if I set up basically the side as the diameter of the inner circle, let's have a look. So that's the side and that's the diameter, so they're actually equal. Okay, so diameter of the inner circle becomes the side of the square. So we can say that side of the square is basically equal. We can even set up, well, that's again not working properly. Okay, so that's going to be double radius. So we can set up that if the side is x, we can say that the side x is going to be diameter or double radius of the inscribed circle in this case. So how to figure out using Pythagoras your side x? Simply means that x squared plus x squared, because that's the square, so all sides are equal, and it will be equal to hypotenuse, which is red. In our case, hypotenuse is going to be double radius, or 12 square root of 2, but squared. Okay, 12 square root of 2, which is squared. Alright, so we simplify and we'll get 2x squared equals 2. So 144 times 2. Because later it would say that power 2 goes to 12 and goes to square root of 2. So 12 squared is going to be 144, and square root of 2 squared becomes just simply 2. That's the property of the square root or index, if you use index form. Okay, so from there, we've got x squared equals 144, or x simply because 2 basically cancel. And we've got that x equals square root of 144, or just simply 12. Okay, so we've got that x is 12 centimeters, and because it doubled the radius of inscribed circle is going to be x over 2, which is in this case is going to be 6 centimeters. Alright, so that was solution using Pythagoras. So in this case, we definitely use Pythagoras. However, there is another approach, and even right there, we can use trigonometry. And which way? Let's assume we have the same approach, but we want to find a bit different way. How to use trigonometry? Calculate your side x. So, at the step here. That's using Pythagoras. Alternatively, we can use trigonometry and Trig's ratio. So, to figure out the side x. How we can do this, guys? How we can do? Let's have a look at this triangle again, ABC. Because this is diagonal of the square, we know it becomes the bisector of each angle C and A. So if it's bisector and the angle is 90 degrees, this small angle becomes 45 degrees. So we can say that this value is going to be, this greenish doesn't work. All right, so 45 degrees because it's half. If we use that, we use the angle and we want to figure out basically the side x, let's say adjacent to 45, but in this case it doesn't matter. And we know that AC becomes 12 square root of 2, so we know that. And we can, instead of AC, write 12 square root of 2. We can easily figure out adjacent side. So basically, using trigonometry, we've got this sort of right angle triangle. Okay, that's going to be a red one, and we've got other side which is the same, and we mark them as x. So okay, we need to figure out the adjacent side with 45 degrees angle, and we've got 12 square root of 2. Okay, so using tricks, probably it's much easier because you immediately find x instead of doing several actions in simplifications. Alright, so what do you think about x? X is adjacent, so we use cos, right? So we use hypotenuse square root of 2, 12 square root of 2, and multiply by cos 45. Hopefully you know that cos 45 is square root of 2 over 2. If not, just try to use calculator and you'll get this value, or you'll get decimals. No matter how you calculate, so for example, I can do it manually without using calculator. We've got 12 square root of 2. Let's do that. Square root of 2 times the same square root of 2 and over 2. Square root of 2 and square root of 2 will give you 2. 2 and 2 will be cancelled, so x becomes the same 12. So in this case, I think that trigonometry works faster. So in case you know the angle, you can use that and apply trigonometry. If you have no idea about the angle, like in other cases, you would better use Pythagoras. Alright? That's one version how you might solve. Okay, just try to have print screen and let's compare it with another way how you can do alternatively. So for example, again you have the same problem, and in this case what I'm gonna do, instead of drawing diagonals all along through basically the square from one angle to the opposite, I just have it, okay, and I simply put another line which is the radius of the inner circle. So I can write that this is the radius of inscribed circle. Okay, we also have this red line, and because if we connect up to another angle, we'll get diameter, but in this case it's only the radius for the big circle. So in this case it's going to be 6 square root of 2. So we know that this red line, red segment, is 6 square root of 2, and we need to find inner or inscribed circle. Okay guys, now it's right time to apply trigonometry. This angle, as we noticed before, it's 45 degrees. So what we can do, we can consider that triangle with sides are inscribed, known size 6 square root of 2 as hypotenuse and 45. Why this triangle is a right angle? So we have a tangent because your circle is inscribed in the square. So that means touching point, okay? this is the touching point. And that means using the property of the tangent line and the radius of the circle, so we can figure out that this angle is 90 degrees. Okay, so using that, we can easily calculate inscribed radius, or radius of the inscribed circle, as simply 6 square root of 2 times, in this case, sine of the angle 45. So sine of 45 equals to cosine 45, and if you calculate, that's going to be the same, square root of 2 over 2. And if we plug in, we just simply can say that we've got almost the same. And now square root of 2 times square root of 2 will give us 2, and 2 will be cancelled with 2, leaving us with our inscribed circle, radius of inscribed circle, to be just 6 centimeters. Alright, so pretty elegant solution. And now you guys think that your solution will be dependent on how you consider the problem, which segments and where you put them. Okay, so that problem is typically for GCSE Higher or iGCSE Extended, so make sure you understand that. In this case, we figure out that x is simply 12, so the same answer is 6 centimeters, because our inscribed is x over 2. So however, we use a bit different approach. I mean, we consider different elements in different triangles, while here it's pretty compact. So guys, your solution will be dependent on your experience. Okay, it's not about like you need to be really smart in order to find that. I mean, just that's about your upgrading. So like consequently, you understand which way probably can give you a fast track, and you, so that you can save your time on exams. Okay, but that comes, you know, during the years of practice. So if you're on the CC, so, and you, for example, 1 year is already gone, so that's the right time to get prepared for the next year, for the final exams. So guys, getting ready, try to go through different problems, try to go through my revisions. You will find it very useful for other topics. Trust me, if you go through, you'll get enough practice in order to solve at least these topical problems. So the video is updated on a daily basis, so don't forget to subscribe in order to get in touch with me on every day. And for sure, drop the comments. I'll always give you feedback. Thank you. That was Daniel Dallas, and see you later.